Recording to the cloud. So last time, if you were here in class or if you watched the video, we did this. We talked about expanding our universe of numbers. And we created these things called complex numbers. So where did they come from? Well, real quick, we had this definition. This is all the new material in this section right here. Everything we do with this definition is stuff that you hopefully know how to do from introductory algebra or other algebra classes. The imaginary unit, I, is this definition right here. I is the square root of -1. So anytime you see the square root of -1, that becomes your imaginary unit. The corollary, the extension of that definition is this, that whenever you see an I squared is equal to -1. Okay, so that is the definition. Then if you remember in the previous video, what we did is we talked about writing things in terms of the imaginary units. So you can watch part 1 if you weren't here. And then this is where we ended. We defined what a complex number is. Okay, so a complex number is any sort of binary number like this, A plus BI. A is the real part, BI is the imaginary part. So now, any real number that you've been using is a complex number just with no imaginary part. Imaginary numbers are complex numbers with no real part. And then you have the two-dimensional complex numbers. Okay, and so working with them is always the same. So what we are going to do, the way we're going to finish out this section is we're just going to talk about adding, subtracting, multiplying. If you take college algebra with me, then we will talk about dividing. We could talk about it here. You know everything that you would need to know to do it, but it's not relevant to your final exam experience in this class, so I'm not going to talk about it. So we're just going to each do an example of these. If you have any question, please let me know. So first, adding. Well, this is a blast from the past. If I had this, if we had, let's say, something like 5 plus 2x, and we were going to add that to 7 plus 3x, okay? I'm not going to do that problem. I'm just likening what we're about to do to something that I know you already know how to do. What would you do here to add these things? Not foiling, that's multiplying. We'll talk about that in a minute. Combine like terms, excellent, well said. So we would combine the 5 and the 7 because they don't have a variable, and then the 2x and the 3x because they do. Well, the good news here is that adding complex numbers is just adding like terms. Okay, so if I have 8 plus 3i, and I'm adding, okay, so that this plus sign between the parentheses is important. If I am adding to -2 plus 14i, I just collect the like terms. And so what I have is 8 plus -2. 8 plus -2 is 6. That's my real part. And then my imaginary part, 3i plus 14i, is a positive 17i. So there is my answer, 6 plus 17i. It's just collecting like terms. So please, if you would, take 20 seconds or so and do exercise 6 right next door. Once again, I have an addition problem. I'm going to highlight the plus sign because I want you to be doing the right operation. And so when I add, I just add my like terms. I add my real parts, I add my imaginary parts. So the real parts, -11 plus 14, that is a real part of 3. And then the imaginary part, 17i plus -12i, 17 and -12 is plus 5i. Anybody get something different that we need to talk about before we move on? That's all the addition that I have for you. All right, well, oh, actually, there is one more addition. You're going to do it. Exercise 7. Instead of 2 complex numbers, there's 3 for 50% more fun. All right, so I'm just going to add my real parts. I'm going to add my imaginary parts. So again, it's all addition. So -6 plus -5, that's -11, plus 7 turns out to be -4. That's my real part when all is said and done. Then my imaginary parts, 2i plus -14i, that's 2 plus -14 is -12, plus 6 becomes -6i. Good? All right, well, subtracting is next then. So my next example, 4, is a subtraction problem. Now, you can do this without writing the following down, but I will just tell you, students are prone to mistakes if they don't do this step. So I'm going to advise you to do it. I am going to, before I worry about combining my like terms, I am going to distribute that negative. Because what inevitably happens, I see this over and over every semester, students will accurately do 8 minus 2 and get 6, but then we'll forget that there's a subtraction and then do 3i and -6i and get -3i. That'll be wrong. Okay, so I'm going to just say, okay, I've got 8 plus 3i. Now I'm going to distribute that negative, and I have -2, and then negative is +6i. So taking the time to do that one little thing will be helpful for your accuracy, and I want you to mop up these points. When I put a couple of these problems on the test, these should be nice, easy, quick problems for you to do. So 8 and -2 is 6, 3i and 6i is 9i. There we go. That's my final answer. So I would like you to do the next one, please. Exercise 8. All right, so exercise 8, again, I am going to take the precaution of distributing this negative. So a negative times a positive is -8. A negative times a negative is +5i. And now I'm going to combine my like terms. -12 and -8 is -20. And 3i and 5i is 8i. Last problem of the adding and subtracting variety is exercise 9. It's a mixed problem. There is an adding and a subtracting. So give it a whirl. All right, once again, I mean, if you can do this in several different ways, like if you want to just do the addition right now and then distribute, whatever is clever. I'm just going to rewrite the problem and distribute, and then I'm just going to add it all in one step. So I've got the 13 plus 7i, I've got the 2 minus 9i, and then a -3, and then minus 7i. However you did it, though, this is what you should end up with. We all should end up with the same thing. 13 plus 2 is 15, minus 3 is 12. And then 7i minus 9i is -2i. And then -2 and -7 is -9i. Before we move on, we got one more operation. Any questions, comments, concerns about adding or subtracting our complex numbers? All right, well, here we go. The last thing then is multiplying. Okay. Multiplying, again, is just like algebra. It's just either distributing for a problem like this or foiling if you've got if you've got binomials. So here we go. I'm going to do this first one, example 5. So I'm going to take 5i, I'm going to take that imaginary number, and I'm going to multiply it by the complex number 6 minus 4i. So here we go. 5i times 6. Well, what's 5 times 6? 30. Yeah, there we go. 5 times 6 is 30i. And then 5i times negative 4i. Now let's be careful here, and because we're going to have to draw back onto the definition. So 5 times negative 4 is negative 20. And then I times I is what? I squared. Now, we struck on this last time, but I know that was a few days ago. What is I squared defined to be? Let's flip back to the front page. What is I squared defined to be? Negative 1. Everywhere you see an I squared, it becomes a negative 1. So this term right here, instead of negative 20 times I squared, is negative 20 times negative 1. And what is negative 20 times negative 1? Positive 20. So I'm going to write that first. It's not wrong if you write the real part second, but it's proper to write real part first, then imaginary part. So 20 plus 30i is the answer there. I'd prefer it if you would write it in that order. I won't mark you wrong or take a deduction on the test, but it's a good habit so that when you're doing things with your complex numbers, you got the real part first. All right, do exercise 10. Take care of that distributing, please. All right, so here we go. I'm going to distribute, check your answer with my answer. If you get something different, that is a great opportunity for a question. So negative 3i times negative 6, a negative times a negative is a positive 18i. And then the negative 3i times the positive 12 is negative 36i squared. And then once again, I squared is defined to be negative 1. So that is negative 36 times negative 1, or positive 36. Plus 18i. We good? You catching on? All right, I've got one more example I'm going to do in this section, and then you've got 3 more that you're going to do as we just finish up. Okay, so just don't forget, I squared is negative 1. So here we go. I've got 2 minus 3i times 4 plus 7i. I'm going to multiply these two complex numbers together. It's just foiling. Somebody mentioned that earlier. We FOIL, we use that acronym when we multiply, not adding and subtracting. Okay, so keep that straight. So here we go. First, outers, inners, lasts. When I do my first, 2 times 4 is 8. My outers, 2 times 7i is 14i. My inners, negative 3i times 4 is negative 12i. And then my lasts, negative 3i times 7i is negative 21i squared. All right, there's 2 things I've got to do, and then I'm done with this problem. Somebody tell me what one of those things is. Okay, I heard both of them. So first thing is I got to change that I squared. So what is I squared, what is negative 21 times I squared? What's that going to be equal to? Okay, I'm just going to, if you don't mind, I'm just going to draw a little arrow and say that that's a plus 21 now. Okay, just so I don't have to rewrite everything. So I have 8 plus 21. My real part's 29. Everybody tracking with where that number came from? The other thing that I heard somebody say is we're going to combine like terms. I got those i's. So I've got 14i minus 12i. That's plus 2i. And there we go. We're done. There's my complex number answer. So we're going to finish this sheet one at a time. So I'm going to give you about 30 to 45 seconds to do exercise 11. All right, here we go. First, outers, inners, last. Check your work with my work. Ask questions as necessary. So my firsts, -1 times 4 is -4. My outers, -1 times -I. A negative times a negative is a positive 1I or just plus I. My inners, -6I times 4 is -24I. And then last but not least, a -6I and a -I. A negative times a negative is plus 6I squared. Anybody get something different there that we need to talk about before I finish this problem up? Okay, so once again, the two things that I have to do, the 6I squared, that's going to become a -6 because I squared is -1. So I have -4 and -6, that's -10. And then 1I minus 24I is -23I. If you feel good about it, let's do exercise 12. If you don't feel good about it, ask me something so we can hopefully feel better about it. First, outers, inners, last on exercise 12. My firsts, 7 times 3 gives me 21. My outers, 7 times -2I is -14I. My inners, 2I times 3 is plus 6I. And then finally, my last 2I times -2I is -4I squared. Okay. Stop me if you got a problem. Stop me if something's not clear. I'm just going to keep going here. So -4I squared, what does that term become? +4, yes, well said. Thank you very much. And so 21 plus 4 is 25. -14I plus 6I is -8I. And there we go. There is my complex number answer. Got one more problem, and then we are done with multiplying unless somebody needs another example. So go ahead and finish up. Exercise 13. All right, my last one, first outers, inners, last. My first, 5 times 6 is 30. Outers, 5 times 3I is 15I. Inners, 12I. And then my last 2I times 3I is 6I squared. And there we go. 6I squared becomes -6 because that I squared is just defined to be -1. That's the definition that preceded everything here. So 30 minus 6 is 24. 15 and 12 is 27I. And there is my complex number answer. Anybody got a question, comment, or concern before we shut down this section right here? All right, then that's all she wrote.